and be very thorough with your maths in terms of visualizing. So for your convenience, I have already shared the insights I had after running a few tests on the data in the data preparation bullets. I'll be first of all describing each of them. So the first function in pandas is something called df.describe. Everybody starts with this for our exploration of data. So describe basically tells you the count, mean, standard, minimum, maximum, interquartile ranges. What are interquartile ranges? I'll be posting a blog later on, which I wrote for Maths for Machine Learning, and had good reviews from different people. It covers almost all aspects. You can go through that. I won't be getting in depth, but these are some important mathematical features as of now you can understand, which we need to think, right? And on a very simple general note also, if you see, we really need to identify which is the mean, which is the standard deviation, how much data is distributed towards 25% of the data, how much data is distributed towards the 75% of the data. By that I mean which fraud transactions are more populated towards only 25% set of data and which are more populated towards 75%. That is something we need to identify. Another thing which is important is we need to identify columns. So pandas give you a very good easy way to just see the columns, which is literally df.columns, and you get to see your columns in your data. So I can see that there is something called time, then v1 to v28, amount as well as class. The next is the most important thing. Fortunately for us, there is not any null values present in it. So the next thing is calculating how many missing values are actually there in our data. So if there are missing values in our data, we can't really directly proceed, because as we already emphasized on the idea of imbalance classification, if there are missing values, that means there will be a bias towards the column which has more number of values compared to other columns which doesn't have that many values. So that might actually lead to a bias in the model. Fortunately for us, we checked for missing values in our data, which is completely zero, as you can see. How do we check? df.isNA, this actually returns the total number of null values in a column. And when we are doing dot sum, it returns the total number of sum of entire missing values in that particular column, and not just tell the value entries. So as you can see, from V1 to V28 and the amount class, all of them are completely filled. So there is no missing data, and therefore we don't need to really handle it. So you can see that these are the insights which I took out from our entire very simple exploration. In fact, we haven't done the exploration that we'll be doing in the next. So we already observed there are no missing values. It has only one target variable as categorical variable, which is class 0 or 1, and the remaining features are numerical and need to be standardized. That means for comparison, we need to bring them to a similar scale. Why we need to bring them to a similar scale? For example, in our day-to-day life, when we go to the market, if I am buying milk, it will be measured in liters. If I am buying ghee made out of milk, it will be measured in kg or kilograms. Now, in order to compare a ghee with milk, this will be injustice until and unless both of them are of the same unit, or rather of the same scale, either liter or kg. So for that, on a similar note, when we are handling data, it will be very unjustified if I am comparing time, which might be in seconds or milliseconds, to something like amount, which might be in dollar or rupees. So how do we compare this? We will be coming to that idea downwards. So any doubts before we actually proceed towards the exploration data part? No? If there is any doubt, you can just post it on. Cool, I'll proceed then. So now we need to actually visualize our data properly. What's actually happening in our data? So the first thing which we'll be making is something called a count plot. A count plot is basically a data visualization function which literally simply counts how many values are present. So as we already saw that we imported some few visualization libraries, matplot.pyplot as PLT, cbon as SNS. So we'll be making use of these visualization libraries. So as an inbuilt count plot function which takes all the data, counts the number of instances in it and displays them. So for your convenience, I have written proper comments so that you can understand what exactly a function is doing. Why I have made these two functions is so that I don't have to again and again make a new function for visualizing, because I'll be using them frequently. So it's a healthy practice to modularize your code when you are working in an organization, even for small tasks, so that it doesn't become, it actually increases the readability of code. It might not sound something very important to you as a beginner or as an intermediate, because personally, on a personal note also, it didn't sound it important to me. But once you start working, you really get to realize that something like these is also very important. So, and the second one is a function which I made for making scatter plots actually. Now, what are scatter plots? For example, scatter plot is basically something looking like this, which distributes all the possible data points in the entire data set, or rather, which we call in technical feature space. And we actually calculate which points are more related towards one another. So that is something called scatter plot. The major use of a count plot, the first function, is to count the number of instances having same value. And the major use of a pair plot or a scatter plot is basically to understand the distribution of the data and to understand how two variables in our entire data set are related to each other. So I plotted the count plot of the data, and as you can see, the amount of difference in terms of the number of legitimate transaction, which is 0, and the amount of fraud transaction, which is not even properly visible on scale here. So it means it is highly imbalanced and we really need to work around things. So it's very important to convey your insights at the same time. So I have written already so that you can understand that the data set is highly imbalanced, as we already see from the count plot, and it has 32 columns again, which I have reiterated, with 2 classes. Now we really need to solve this problem. Now first of all, we'll be answering our first question. Our first question was over here. Okay, first the second question I have answered, sorry. What are the general trends in amounts of credit card fraud transactions? So which amounts are mostly fraud? So I just made a scatter plot intentionally of only time, amount and class features. Okay, and when I made this, I saw that fraud transactions, which are 1, as you can see in the legend, are basically of a very low amount. You can easily point it out that there is no fraud transaction above 5,000 rupees also. All the fraud transactions are actually below 5,000. And if you look closely, the highest probably is this one only. That might also not be 3,000. So this is something of an unusual pattern which I noticed in data, right? Just by looking at the data. But just by looking at the data, I can't really tell my employee, see, I have seen this much, is it? So probably there is no, I need to. So I just made a assumption or an hypothesis that yes, all fraud transactions might be of an amount less than 2,500, as in this case I have looked at. Okay, now I really need to go and prove my assumption to my employer or organization. So what do? I'll just go. Before that, I'll also make a pair plot, scatter plot on a vertical scale to ensure that I am not missing any points, just to be on the safe side. So I just made this one again, and I can also clearly see in this that yes, in the amount, nothing exceeds 5,000. So actually nothing exceeds half of 5,000 also, if you see. In the vertical scale we can see. So that is the case. Nothing is above 2,500 also. So to prove it, I will use basic Python. As long as you know your fundamentals, you are pretty much good to go. Never ever try to overcomplicate things in machine learning. I feel today people think machine learning is all about some magic over there and try to make different ideas, try to apply so many complex models, but they forget the crux of the matter is that we need to solve our small problems with machine learning. And for that, sometimes only Python is sufficient. So in this case scenario, what I need to do, I just need to confirm how many amounts are fraud below 2,500 and how many amounts are fraud above 2,500. So I just traverse the entire data set or data frame through this for loop. And if I feel that the data frame has an amount less than 2,500, I'll just increase the count of my amount less by 1. else I'll increase the count of more. I think this is pretty much clear even to non-coders. I have made it very simple. So you can see that 449 is the value returned for amount more, but 2,84,000 is the amount returned for amount less. So almost all the fraud transactions, that means nearly 99.84% transactions, which actually is around 99.85, is less than 2,500 rupees. So there might be one or two above it, but mostly are below 2,500. So to adjust things, we can go to 2,500 also, and we can take 3,000 also threshold. That's up to you. I have in the example taken 2,500. So now I just count the number of fraud and legitimate in a similar fashion, just like above. Now, anybody having a doubt, what does the ilog function do? Ilog function basically is used to identify a particular index in a data frame. So for example, when you're talking about a data frame, as in this case, each of these columns have an index. For example, we start counting from 0, 1, 2, 3, 4, 5, 6, and so on. So the ilog function just goes to that particular index which is there, and then it checks. So in this case, it goes to each and every index since we are starting from 0. And df.shape0 means the number of columns. So similarly, we actually make a pair plot of the time amount class as well with the actual label, which is the fraud or not fraud. And we can very clearly see from the last one that all the fraud transactions definitely lie below 5,000 and below even 2,500 easily. At the same time, we need to now answer the next question. So for first question, we easily answered that the number of fraud transactions are pretty much below 2,500. We had made a hypothesis about it from the scatter plot, and then we confirmed it with our basic code. So this is how you actually go about in a real-time data case scenario also. That is also no different. You need to make a hypothesis, then you need to prove it to your client or your employer or vice versa, whatever is required. Then the next thing which will be going is the next question. What is the relationship between time and transactions? So for that, again, I made a pair plot, but in this case, I mapped it to a distance plot. Distance plot basically means that I'll be measuring each of the variables. That means in this case, what are the different variables? Time, amount, and class. Class is the actual label which I need to tell, fraud or not fraud. So I'll be assigning this. And when I labeled only time with the class, ignoring the amount, I found this, that almost all fraud transactions are very nicely equally distributed. So now when the data is equally distributed among your feature space, then you really can't go and say that boss, this plot, I can very clearly say that fraudulent transactions are exactly spread throughout the time period. Basically how you explore different sort of data. Of course, there is a huge amount of other things which we need to do, but the major crux of this is that we needed to answer those questions which the employer has given us. Obviously, there will be many other questions related to data. I am moving on. Is modeling. Okay, so now in modeling also there is a lot of data exploration which people